It's my pleasure to introduce Max Peterson and Bugs. Bugs with a double G, by the way, just for the record. Max and Bugs are going to be talking to us today. And Max, let me introduce Max first, I had the pleasure of working with Max at a former company, and he's come over to Ziffo a couple of months ago. He's responsible for developing the digital strategy, especially for lab automation systems. But Max has been in this industry for 20 plus, I'll give a plus, 20 plus years. He has experience in informatics, simulations, technologies, across life sciences, chemicals, materials, and so forth. And then we have Bugs, who will be speaking with him, who is the Vice President, Solutions Division at Ziffo. Bugs comes with 25 years plus experience in consulting, experience and primary focused around solution architecture. He has worked with several life science organizations to provide architectural and technical leadership for strategic lab informatics initiatives. Prior to his current role, he's focused on building ELNs and LIMS system capabilities. And essentially, the two of them are going to be talking to us today about solving the lab data automation challenge in diverse R&D IT environments. So welcome, Max and Bugs.
Yeah, so thanks, Margaret. First of all, I wanted to say I could have put a subtitle, but the title was already so long. And obviously, the subtitle would read something like, what are the opportunities of tackling lab data automation from the context of a services organization? So this is actually something that has interested me throughout my career quite a bit. And when I started to talk to Ziffo, and especially Bugs, I was really excited to take this position and start to work with the team. And so far, I've been incredibly impressed. So I don't think we need to say much about why we are interested in lab data automation. It's a top priority across R&D and funneling down to QA, QC. And there are, I think, three main areas that I have known from talking to customers that are really the key drivers behind that. Yeah? That is, of course, data-driven R&D. We've heard a lot about data strategy. And we've seen that lab instrument data are the basis of this knowledge pyramid that we're trying to build up. And then there's, of course, verification of data, right? And you could say, well, that is actually connected to data-driven R&D, but there's, of course, arguments that go beyond that, right? There is the collaboration argument, the compliance argument, and also efficiency argument. And then there's, of course, the impact on the lab operations, right? It's a way to drive efficiency and throughput. What we really want to talk about is the difficulties. And I maybe shouldn't have said but it's notoriously difficult, but it has become has been a goal throughout many, many years, but it's now becoming feasible and tractable, right? So it's an aspirational technology, but it's becoming feasible. But there are three areas that mainly drive this complexity. There is the dynamic instrument landscape. We've talked a little bit about that during Neil's presentation, right? Most instruments outlive PCs that control them, or even operating systems. So that is always going to be in flux. It's always going to be dynamic. There's going to be acquisitions, decommissioning, and so on and so forth. Then there's the end user data provisioning challenge. There is a very diverse, we have seen all these portfolios of end user applications that need to be supported, and ultimately the data need to be provisioned to these systems. It's not enough to put it into a cloud and having sit there. It needs to get to the ELN, LIMS system, or analytics capabilities that we need to do. And it's, of course, a very complex system integration problem. And I really want to talk more about the aspects of lab data automation in the context of middleware. And it's at least an experienced services implementation partner or somebody who can tackle this. And I think it's really good to look at this problem from that context, to say, well, at the very basic level, what we're trying to do is to connect the data stream from the instruments, ultimately to the productivity systems. There has to be, of course, a data persistence or a data provisioning layer. And as companies are moving more towards cloud data platforms, it's, of course, becoming more of a middleware challenge to really connect the instruments to that cloud data provisioning framework. Traditionally, we have dealt with SDMS systems, or for very focused efforts, we may just work on top of the app data storage and maybe have some supplemental systems that can connect large volume of data directly to the end-user application storage systems. There's also the more advanced lab data automation challenge, which is the integration into the workflows. That, of course, a experiment is not like a straight line. It has many steps, and there's a data orchestration and metadata enrichment problem that is added to this. So on the services side, there's, of course, things like existing infrastructure, there is business objectives, there's the specific science, and so on and so forth. There is implementation. And from our perspective, I think also the parser challenge should be put on the services side of the equation, because these servers are never going to be static. You're never going to be done. Every lab will have different lab infrastructure. So the idea that you would have all of these parsers out of the box producing all the data in the right way is simply an illusion, because a lot of the metadata is actually encoded based on business rules into the file formats, data structure, how a business stores them. So this is always going to be a services-driven exercise of getting all the parsers right. But there are, of course, something that we would want to maybe call universal capabilities that you need to build at the level of an enterprise-grade application framework. They need to be scalable, they need to be robust, secure, and so on and so forth. And this is kind of what Bugs will tell you later about how we went about that. So in summary, basically what we did here at Zifo is to pre-build some of these capabilities, to basically fulfill some of these requirements. And we're thinking of them more as an accelerator to a service deployment, right? We're pre-building certain capabilities that we can modularly deploy. They're enterprise grade and they are modular. That means we can work with what you already have. It's agnostic, all the things that the service provider has the luxury to do. And then there's, of course, bottlenecks that a service company can address, right? And that is the scalable parser provisioning, and of course also a team that knows how to operate in this very specialized environment, right? Nia has already talked about that. So in terms of these pre-built capabilities, we put them into 3 different buckets. There is the instrument integration part that takes care of data ingestion, translation, and connector to the productivity systems. There is the lab workflow orchestration, which can take care of ontology annotations, metadata enrichments, and orchestration of data flow. And then there's a utility program in the case that there is no cloud data platform available, and you need to have a supplemental piece of infrastructure to store data. And that can also be validated and also provide like multi-level storage for archiving and long-term data retention. So here's the team. Max is the mastermind behind this. He will talk about the architecture a little bit. But then we have 2 teams. One is around the services engagement. That is really skilled in the services delivery. in the building of parsers. And then we have a team around the creation of these pre-built capabilities. And they are basically just another luxury that Ziffo has as a company, that they can find talent that really knows scalable cloud infrastructure and cloud technologies to really being able to pull this off from a technical team. They have also extensive QA, QC, and DevOps capabilities to basically provide these capabilities at a high quality standard. So, and then there's of course from the Digital Innovation Services team, Aishwarya and myself. And then some of the other things we should mention is that this effort actually started quite a while ago, right? That this started with several one-off engagements. Then the team was built about 3 years ago. So there's quite a bit of manpower that already went into building these capabilities. And there's already some very successful engagements in the field, spanning small molecule, bio, and material science applications. Just a word on the parsers. So with the limited engagements that we have done, we have already amassed 250 parsers that are available out of the box, but we still have a large team working on this to really be able to do this. So it's a massive effort. There's also quite a number of applications already in the field, spanning everything from flow cytometry to assay prep, QA, QC. And we have also built already quite a number of connectors, right? That of course leverage the appropriate APIs. So for example, if you connect to Benchling, you have to own the lab automation API to basically connect to the correct templates. So just to round this here up, two success stories, one from a large-scale analytical and QC lab, spanning like material science and others. So we have a large number of instruments supported here. 25 were actually built for this engagement. We also built a generic LIMS framework to basically connect and then apply that to Labware and Sample Manager. Build connections to Empower. So quite an effort, and all of this is actually operating today in a GXP validated environment. Then here, something that hits probably a little bit more closer to home, large molecule research. And this is speaking more to the capability of really capturing data workflows and orchestrate data across workflows. So we basically built 21 workflows and also integrated 12 productivity systems. So before I hand it over to Bugs, I thought we watch a short video together. So this is just to show you how basically there's a self-service aspect to the solution, to that reference implementation here, where you can basically do basic administration of your labs yourself, right? You can pick instruments, associate them with specific labs, pick the file type or the instrument interfaces, and then point them to the storage locations, and then basically assign, if this is a file watcher application, what schedules you're doing, assign the parsers, and then basically also choose your data archiving options, and then a push into external systems. So that's basically what we're seeing here. Yep, so this is basically the raw and parsed data that are now put into specific locations. Type. Yeah, I think you shouldn't be too hung up about the specific implementation here. This is just an example how this could look like. But the idea here is that once you put a system like that in place, you have some basic administration capabilities that allow you to manage the system autonomously. Right, and of course on the execution of these pipelines, they will be, of course, run behind the scenes, but you can visualize the data flow and you can put some logic into the data pipelining. You can do duplicate checks. You can check that the parsing was successful. And then here graphically see where you're basically going to be directing the data to. So I'm just going to show briefly here how the data basically now sits in the repository. And you can see, first of all, the data structure, and then also associated with that, the proper metadata. So really the point of this video was more to show that this is a real thing. It's not slideware. Now I'm going to hand it over to Bugs, who can talk a little bit about the architecture. So thank you so much.
Thanks, Max. Hello, everyone. Max was showing in terms of what we have been trying to do. Now I'll just focus in terms of some of the experience that shaped this solution, right? The challenges, the struggles that we went through over the past 10 plus years, learning this space and evolving this solution. So this is something that we have been working at a number of customers over the years. We have started working in the EL and LIMS space 13 years back. And right from the very beginning, we used to work in terms of a number of instrument integration. If you look at the earlier days, there are a number of organizations that just don't capture the instrument files or probably dump it in some of the file shares. And then customers used to approaches building some solution in terms of probably keeping it in some location, a safe location like say SharePoint or a file share where it could be archived. So we used to build some custom solutions around it. And then we used to build some of these parser scripts that will take like the text files, the Excel files that are exported from the instruments, build each of those line by line. We used to look at those specific points and build parser scripts. And we used to integrate it with the ELN and LIMS. So that's how the initial experience started. And we started working on hundreds of instruments like that over the years. And then as things evolved in the 2015 timeframe, what we observed is there was a strong focus in terms of data standardization, right? Things like animal allotrop evolved, and people started approaching us in terms of, can you read the raw data, help us standardize it? And we started working on a number of such custom solutions where we would focus on specific instruments, instrument software like Empower, Chromeleon, Softmax Pro. We started building some specific custom solutions that kind of standardizes some high priority data. And when some of our customers were looking at doing it in a larger scope, it was always a major challenge. It's a nightmare. It's a large effort. And people pretty much stopped going there and just focused in terms of some of the key instruments. And this is something we started coming across a number of customers. And we saw this is a need that was evolving, and there was a major gap out there. And that's how we said, okay, why not we build a standardized solution, right? We are building a number of custom ones. Let's just standardize it and help our customers to accelerate this whole implementation. So this is how, in 2018, we started focusing on building this as a solution. And some of the key considerations when we started looking at it, one, I think, this is something that would be familiar. Typically, when you go into a lab, you're coming across a number of instrument types, a variety of models from different vendors, each of them having their own data format. Sometimes it's a vendor-specific custom format. Sometimes it's like export of Excels or PDFs. And we were essentially, this area that we were looking to solve with a generic solution. And this is something where we looked at like how we could solve this through a standardized solution. And one of the first things we started doing is like what we today call as parcel libraries, being able to build at one customer and being able to reuse it across customers, help customers accelerate the whole. So we used to basically take the essential knowledge in terms of how the specific instrument format works, how the specific APIs work, and being able to leverage to build a standardized solution around this. So this is how we evolved. And we went through our own set of challenges in this. What we had seen is, while we tried to standardize the data from the different instruments, every customer started adding their own data on top of it, and it was not easy to standardize. So we also kind of learned through the experience, started building in terms of separating the library into two components in terms of a standardized data model that we could offer, and then add extensions to on top of it. So that way you are able to ultimately get your data model, and you could do it fairly quick. Take our library and then add your extensions on top of it, and you'll be able to quickly get there. So that's how we started evolving this part. And so then we started looking at in terms of how we could occur this data. And again, we're building several of this custom solution, variety of technologies. We used to build in Java, .NET, Python, cloud. And then we said, okay, let's standardize this part, and let's offer the overall data capture in terms of focusing around data integrity, the validation aspects, and ultimately provide a solution that could leverage this parser library, be able to occur the data from different instruments. It could be instruments that support some pretty old legacy technologies like the RS-232 serial port, or files, or it could be some of the recent ones like the OPC protocols, REST API. So we started addressing in terms of this technology challenge to occur the data from the instruments, and then being able to parse it, standardize the data, and feed it into your target systems. Could be your ELN limbs, or could be your archive, ultimately routing it to the location where you want to keep this data, and probably look at further analysis as per your data models. So this is one part of the solution that we looked at solving and evolved over the years. And the next part that we then started looking at is the scale, right? So this is something where we had seen to several of the customers who have hundreds of instruments across sites. And there have been some interesting cases like several of the instruments are run in the morning, and then people try to process all of the data, typically around this time. After 3, as people try to go home, everyone dumps the data, and there is a major spike in the system. And also like huge size of the files. There are like flow cytometry files that we handle like several GBs size, or image files that come with a huge size, versus high volume ones. It's pretty small data, but thousands of them that hit us all through the day. And we had to balance it across the globe with a multi-site environment. So a solution that could scale both horizontally and vertically. So this is again something we started looking at. And yeah, so these are some major challenges that we focused on. But apart from this, from a overall services perspective, we also looked at like how when you enable the parcel libraries, we offer it to our customers. We looked at giving it in an open way, right? Customers take the parsers, they could build on their own on top of it, or they could leverage somebody else to extend it from there. So that's something we looked at, like how do we keep it open, flexible, kind of keep it modularized. You take some specific components, and rest, you could probably address it with some other options. So those are like some key considerations when we looked at it, apart from the scalability, the standardization aspects. And while doing this in the 2018-19 timeframe, what we started seeing is there were some organizations that were going towards the next step, right? They started focusing in terms of a complete orchestration of data across the entire protocol. So typically, there are a number of these cases where you have several applications. You have your registration application, inventory applications, ELNs, data stores, archive, and then you have a number of instruments that are flowing across this flow, and people are moving data across this. So, well, even if you automate one part of it, still there are a number of these applications, and people still have to move the data manually. And this is something we started working with a couple of customers and started focusing in terms of how we could solve it. The other challenge is the protocol variations, right? There are a number of protocols. Each of them have their own process variations that need to be addressed as part of it. So we started working with a couple of customers, building custom solutions for them. And this is something where we again took the services approach. We started building standard component libraries for different integration and business rules. And then we could use some of these low-code platforms and be able to orchestrate the whole flow. Whenever a new protocol comes, you would be able to fairly quickly automate the whole flow across systems and pretty much eliminate the manual intervention. But the other part is also we focused in terms of generating a single document across this entire flow, taking the data from the different systems and feed a single connected data properly verified and feed it into the data source. So that way we are able to enable the analytics. So these are like the two major inputs that went into the solution, things that we did at different customers, and then we kind of built that as a standardized solution from there. And with that, some of the key aspects that we looked at is being able to keep it in a modularized way. You should be able to take it like only specific components. Could be you just take the instrument integration or just the archive part or the workflow orchestration, and you might use some other solution, right? So we kind of kept it modularized. We kept it open where you are able to extend it on top of it. And also being able to manage this effectively between the cloud and the on-prem. So that's the other critical part that we focused. And the solution was architected towards these aspects. And from a technical perspective, from a scalability perspective, again, we initially started pretty much focusing within AWS, but then we saw like customers needed the flexibility. So we pretty much kind of kept it flexible within a Kubernetes platform. You could scale it properly in clusters if required, and you could move it. Today, it's optimized both for AWS and Azure, and you can do it in your on-prem also. So we're pretty much focused in terms of the flexibility, the scalability, and being able to deploy this in any form as per the specific customer needs. So those are like the key aspects that went into building this based on the different experience. I think I'm coming to. Yep. So I'm coming to the end of this. We'll open it for questions.
Yeah, does anybody have any questions for Max and Bugs? Okay, well, they'll be around the rest of the day, so thank you very much. Thank you.